Hello, everyone. My name is Christy Baker, and I'll be moderating the panel today for incident response before the incident. Like I said, I'm Christy Baker, and I'm coming to you from San Jose, California. I'm a former Googler and Netflix employee. Currently, I'm on a break getting ready to have a new baby, but I have over 20 years of experience in the industry. I've been doing engineering leadership for about the last 13 of those years, and SRE specifically for about the last 7 years. So I come to you with that experience, and we have a very a wealth of knowledge and experience on our panel today, and I'm going to let them go ahead and introduce themselves, and we will start with Sylvia.
Hi, everyone. My name is Sylvia Botros. I am a senior software architect focused on reliability at Twilio, which I bet a lot of you use. I have started my career in operations, doing a lot of database work. If you have seen High Performance MySQL, I am one of the co-authors on the latest edition of that. And now my work is more broadly around reliability, working with both reliability engineering teams and across the company to improve our incident response and incident learning.
Thank you, Sylvia. And could you briefly tell us about we have a little icebreaker that we'll include in our introductions, and I should have prompted that. But can you tell us, just based off of the title of this panel that we're going to be talking about today, what does that mean for you, that catchy phrase, incident response before the incident? What comes up for you?
For me, a thing that a lot of teams don't realize is preparation for the next incident is the post-incident review of the one they just had. I tell a lot of my teams that a lot of times today's SEV 3 is very likely at some point in the future the next SEV 1 if we don't actually learn the right things from it. A lot of us have been in near misses, and those are usually good prep for the next incident.
Oh, today's SEB 3 can be tomorrow's SEB 1. I hear you. Thank you so much. We'll keep moving on with our introduction of our panelists. Sahel, would you please go ahead and introduce yourself?
Thank you, Christy. Hi, my name is Sahel. I work as a principal engineer at a company called Monzo. We are a bank based here in the UK. We have a full banking license, and we run very reliable systems so that folks can access their money. I have been in this space for nearly a decade now, sort of building high performance and highly reliable systems that sort of get out of the way so that engineers don't really notice them. We always like to say that platform teams are only really called on when things go wrong. They're only really noticed and only become visible when things go wrong. So we try to make ourselves as invisible as possible in that context. For me, incident response before the incidents, what does that mean for me? It's about building good sort of teamwork and empathy, knowing who to call, knowing who to rely on, knowing like what your tools and processes looks like, having empathy around this sort of incident management process so that when the incident is actually happening, knowing who's picking up what and what your communication patterns look like, and making sure that you have highly effective resolution and post-resolution processes.
Awesome. Thank you, Sahil. I really like that you bring that human element to it. That empathy is so important, and also knowing that we are communicating properly. Spot on. Thank you so much for that. Let's keep it moving. Our next panelist I'd like to introduce is going to be Spencer.
Hey, everybody. I'm Spencer. I'm the CTO at Privy. Prior to joining Privy, I was a director of engineering at MailChimp and a VP at Attentive. At MailChimp, I contributed to modernizing the approach to on-call and building incident response processes inside of product teams rather than exclusively at the entire company layer. And I think for me, especially being at a much smaller company at Privy and having smaller teams to work with, one of the most important things here is just being prepared. I think for us, one of the things that we talk about is we want to know that something is going wrong before our customers do, which I think is maybe a given at some of the bigger companies, but is the type of thing that at a smaller company, when your customers are the first line of defense and they're helping you understand that something's wrong in your application, it sows a little bit of distrust that your team knows what they're doing. So we're really trying to lean into that and be able to be prepared and know that our systems are ready and we're able to respond before our customers realize something is wrong.
Absolutely. Thank you, Spencer. Yes, it's always better to know when something is wrong yourself before your customers start telling you, that's for sure. And we'll keep moving on. Last but certainly not least, Hardeep, would you please introduce yourself?
Sure, yeah. Hi, everyone. My name is Hardeep Bath. I'm one of the field CTOs here at Harness, and I've been here for the last 6 months or so, and getting my feet under the table, getting comfortable with the technology and all the other problems Harness is looking to solve across the whole SDLC. I come with sort of a background in transforming large, complex financial organizations like where I was previously at Barclays, heading up DevSecOps for the last 15 odd years. And I kind of had the privilege to kind of lead a number of different transformations in DevOps space, in security space, in incident response, and kind of, you know, the ops management. So I've seen kind of from the bleeding edge, when things do go wrong, they can seriously go wrong and have a major impact. And those impacts can be substantial, especially for organizations like the big banks here in the UK, which are heavily regulated and governed, and they can have an impact on serious impact on the UK economy. So incident response and being kind of, you know, ready for incidents is a massive deal, and getting it right is something I'm really passionate about. So to me, incident response before the incident means embedding resilience directly into how we architect, ship, and monitor software. It's about empowering teams to anticipate failure, not just react to it.
Wow, that's a great segue, Hardeep. Thank you so much for that. Embedding resilience into the software development lifecycle is exactly where we're going to kick off this panel. So let me not get ahead of myself. I want to quickly go over what we are planning to cover today. And we have 3 objectives. First, how to build more resilient systems and respond to incidents before they impact our users, which Spencer talked about that being, you know, an ultimate goal in his intro. Then we have how to connect incidents to code, deployment, and feature flags. We'll get into that a little bit later. And we're going to end up with talking a little bit more about emerging applications in this exciting world that we live in now with AI, and how SRE teams, operational teams, DevOps teams can start to leverage those technologies to help to up-level their organizations and up-level their skills. So with that, we'll get right into it with our first question to the panelists, and I'm going to actually ask Hardeep to answer this question, and then we can take some follow-up from other panelists. But what does incident readiness mean in today's engineering organizations? And how early should it be considered in the software development lifecycle, Hardeep?
Yeah, so readiness isn't just about responding fast. It's about preparing before anything goes wrong. So shifting mindset from reacting, firefighting to proactive readiness. Readiness, in my mind, includes the right sort of tooling, right sort of observability, right sort of culture, having clear ownership and accountability. Readiness should start early in the SDLC and not just left to the SRE. So that's super important. So some of the kind of indicators of poor readiness I've seen before is where you have confusion over ownership during incidents. So when an incident happens, kind of, you know, people don't know what their role is and what they're coming in to solve and look for. So lack of visibility into recent changes and not knowing what's recently changed, what could have an impact, and why the incident happened, not having rollback or mitigation plans. And in contrast to that, some of the signals that I see in strong readiness is automated observability. Every deployment having a rollback option readiness KPIs, MTTDs, MTTCs, blameless retros, right? That increase trust and reduce that tribal knowledge. So these are, in my mind, some of the kind of signals, and kind of we can start to see those signals early and see whether an organization where their maturity level is in terms of being ready and being more resilient in terms of dealing with an outage when that actually happens.
Awesome. Thank you so much for that, Hardeep. So you gave us some really strong signals that we can look for that would be a sign of readiness. But what are some of the poor indicators of readiness? Does anybody have anything to offer on that side of the house? Some of the things that, oh, if I'm experiencing or seeing this going on in my operation, this is a signal for me.
I think a big part of that, like poor signals that I've seen where I've sort of told a team that they need to focus more of their cycles on reliability, is when they have an incident, they're unsure. Like the amount of time it takes to figure out what specific component is the core problem, that tends to be a signal. And if it's in more complex incidents that may cross multiple parts of the organization, if we are spending too much time trying to figure out who to page, that tends to be also a poor signal. Because in my opinion, reliability is not just about the software. The humans who operate these software and who have to sort of wrap their heads around the signals they're seeing and figure out what to do next, that's a huge part of the reliability. Because if teams are approaching with incidents, we're going to avoid incidents from happening, then they will always fail that goal, because incidents will happen, because distributed systems are out to get you. But if you focus on, I want recovery to be as soon as possible, then the only way to recover as soon as possible is to very quickly figure out what's broken. Engineer your systems to accommodate generic mitigations that you can employ. If you build a system that is stateful where it doesn't need to be, and therefore you cannot load shed, for example, you're going to have your incident is going to go longer. If you cannot easily take out an unhealthy host, again, because it has some state, if you can't tell, my life in databases has taught me a lot. If you cannot easily remove a certain host that is unhealthy because it has state that you don't have a clear path to move around, that's going to impact your time. And these are all things that impact your reliability. In my current job, I get to talk to a lot of our larger customers, and I have never met a customer who said, I don't want you to have incidents. Their pain point is always if the incident went longer than we want.
Yeah, that's true. You can't get around having incidents. So that's a great point to make out. And so that's never really a goal. It's never been a goal for me as an engineering leader to not have incidents. But the goal is to be able to respond in the best possible way, most efficient way. So thank you for bringing that up. And I think sometimes it is an afterthought. This is something that, we went through at Netflix about the ownership and how important that ownership is, and knowing who to page, and how you can lose 10, 15, 20 minutes, in an incident really quickly when there's not clarity around ownership. So thank you for bringing that up. Anyone else on the panel want to add anything to that before we move on?
I'll add a perspective again from the smaller company, but when your support team is the indicator that something is wrong in your system, it's a good signal that your systems are not ready and not healthy to respond to that incident. It almost always means that your customers are finding out that something is wrong with your system before your engineering team is, which in some cases means you don't actually even know how long that incident has been going on. By the time a customer responds, the I guess typical experience I have is that it's been going on for many customers and a lot longer than you want to believe. So having those indicators and the automated systems in place to detect and observe the system health is really important. And as soon as your support knows before you do, it's an indicator that something is wrong.
And it needs to be a point of discussion in the post-incident. That's usually a thing that a lot of teams sort of miss. They go directly to the technical bits and not that part of the timeline of well, why didn't we know first? Sorry, Kirsty, go ahead.
No, you're hitting it right on the head. I love it. I love it. It kind of goes right back to where Hardeep kind of started with this question, saying observability is so important and being able to quickly quickly understand what is actually broken in your system. That's how we started this conversation. So those things are important. Doing those blameless retros, I think Sylvia, you talked about how important those are, being able to, come and talk about those things, not just the technical details of the problem, but also the operations and the logistics of how things kind of played out, equally as
Exactly.
important. Yeah.
Yeah,
Thank
I mean, also to pull on the same thread, a reason a lot of folks in their incident reviews have a standard like sort of template question. How do we avoid this incident from happening again? And I tend to like side eye that question, not because it's a bad one, but I feel that it forces the entire group to stay very superficial with the specific incident and kind of precludes them a lot of times from what I've seen from sort of digging deeper of like the exact same incident may not happen again. But if we focus on exactly how this one happened, then the next one is going to look kind of similar, but not quite the same. And we will have prevented ourselves from sort of getting creative with failure. And so what I try to push teams to do in post-incident reviews is think creatively about this. Did this incident happen in your pre-production environment? What could have stopped it from happening in production? What could have stopped it from being a full down instead of a degraded mode? So sort of to instead of focusing on how to prevent the same incident the next time, it's more like how could this have gotten worse?
Yeah, I think that's really important to think about because generally speaking, you're probably not going to have that same incident exactly with that same level of impact. But thinking about, oh, well, what else could have gone wrong? Expanding outside of that box can be really helpful for you in future outages.
Yeah, but I think what Sylvia just mentioned there is super interesting, right? Because that having that safety barrier and having that culture of trust enables you to not be kind of, super focused on how do you prevent that incident from happening again, but like you bring the teams together, you create that safety in mindset and safety in terms of psychologically how do you look at this? How do you learn from incidents? Because incidents are learning
Opportunities.
opportunities, right? Absolutely. So, as long as you can create the culture of learning, you will sort of hopefully start to needle in on the right sort of questions and the right sort of depth that you can go to sort of prevent incidents from happening. I mean, you may not be able to prevent you may be able to prevent the same incident from happening, but you can really miss the learnings from it by looking at it from a very sort of narrow focus, right? And I really like Sylvia what you just said, right? So that I think that creates that culture of trust.
Awesome. Well, I have nothing more to add to that because that blameless culture is so important. And we started off talking about how culture drives a lot of how we respond to these incidents and making sure that we have those things baked in and that people feel psychologically safe, to bring their best selves to retros and to be able to learn and be vulnerable, right, with their colleagues. Awesome. Thank you all for that. We're going to keep it moving. The next thing that I want to kind of shift the conversation to is how do we connect incidents to codes, deployments, feature flags, and things like that? And the first question I have, I'm going to ask Sahel to answer for us, and then we can take some more responses from the rest of our panelists. Who owns change detection and traceability in the organization? Who should own that? Part one. And then who's responsible for ensuring that changes are observable, reversible, in your engineering organization? And is that an engineering-wide standard, or is that something that should be left up to individual teams? So it's a big question, but I'll let you start to dig in.
Oh, one with many opinionated answers, I'm sure, from the panelists. So who owns change detection and traceability? I think it really I think the answer to all of these questions is it depends. But fundamentally, like, a lot of organizations that I speak to, and actually a journey that we've been on, will say, okay, well, we'll get some like developer portal, or, we'll invest in some automation so that we have like centralized change governance and change detection and traceability. And, that's all fine and dandy. And like, you can have some sort of platform, maybe a team maintaining that platform within an organization. That's all fine and dandy. But I think it's the second part of that question, which I think is really, really important, which is making sure that every team is plugged into like, whatever system you have, even if that system is just updating a Slack channel or updating a Google Sheet, a Google Doc, a release notes, call it whatever you like. You can shout it into the void, get a big klaxon every time you do a change. Whatever methodology you have, making sure that everything is plugged in, all systems possible are plugged into whatever like traceability tool that you have is really, really important. Because many of our changes can have second, third order effects, and like in the heat of an incident, as we talked about in the last question, the sort of time to understand the situation, the time to like understand the contributing factors is quite a key aspect to making sure that the incident time is reduced as much as possible. So making sure that you have all of your systems plugged in. Even I see a lot of teams sort of think, oh well, this change I'm doing to a config flag, isn't going to have any material impact, because it's only touching my little microservice over here, or this tweak to the database variable isn't going to have any material impact. And usually those systems are managed through different types of automation to, for example, how you might deploy code. So they might not go through the same level of rigor, or they might go through more rigor, but not through the same change detection process that you might have in the rest of your organization. It's very easy, especially for platform teams and security teams and ops teams and stuff, to carve out their little niche processes that are completely different to how your organization might do sort of change management centrally. So you can have the perfect will in the world and have a really nice centrally managed process, and that sort of fall down when it comes to like some bespoke teams that sort of do something a little bit tangential or something completely different in the way that they do change deployment. So, making sure that you have some way of identifying all changes that go out, and then like, making sure that there's like easy ways to roll back. We were talking a little bit earlier about, incident retrospective actions. Something that I often see is that, was this change easy to roll back? Was the rollback steps actually clear? Like, even determining, okay, this change may have changed some state, but rolling it back means that it's not going to be a problem. We're not going to end up in a corruption scenario or something like that. Is this a one-way door? And making sure that those changes that are one way, that can only be moved forward, are really, really well communicated. The amount of time, especially at like, the 3 a.m. scenario, people deliberating, can I safely roll back this change? Is not something you really want to be deliberating at 3 a.m. Yeah, exactly. During an incident, and like, who knows what you might have got up to in the evening. That sort of led to that situation. So yeah, making sure that people have clarity on what is like easily reversible and what is not easily reversible. I think that applies to everything. Code artifacts, deployments, platform changes, feature flags, config changes. Anything that is changing the stable state of the system, even maybe the number of users coming online, additional load, a marketing campaign, all these external factors are also pretty important factors, that are like really valuable pieces of context, even beyond engineering changes. You might be investigating why there's a significant uptick in load at your edge one day, and it turns out someone's been running a viral TikTok campaign in the marketing team and forgot to tell engineering. Or like, might have told engineering like, 10 weeks ago that some load is incoming, and now it's causing a problem. I think these things are really, really material factors.
I think that brings a very good point, and it reminds me of something that I've been working on recently, where I don't see enough not engineers, I don't see enough orgs in general recognizing that those mental boundaries between like IT, marketing, and engineering sometimes can prove to be a myth. For example, like it's April, so I'm going to bring it up. It's about exactly a year ago when CrowdStrike, which tends to be in organizations managed by IT, took out entire businesses. And so part of preparing for incidents is to think about risk vectors. And I think engineering leaders, especially, like that may not be quite in the scope of an engineering IC, but it's an individual contributor, but engineering leaders and like leaders of the business at large need to think about, well, where do I have risks to the business that are not necessarily owned by engineering? What if a thing that is run by IT is down? Can we not push things to production? What if, something happened, I don't know, to our chat process, like what do we have workflows that are in Slack that are business critical that we didn't think about, what happens when if Slack is having an incident? So again, this really goes back to being really creative about what things can go wrong, which is a strange mindset to have. We tend to sort of build things and hope it works for the best, but sometimes thinking about what's the worst that can happen can really help future you a lot.
Yeah, I think everybody kind of learned quite a lot from that CrowdStrike incident, right? And I think the whole industry sort of, it was a bit of a wake-up call to the whole industry in the kind of in the way that nothing like that had ever happened before, or we hadn't anticipated that, right? So I mean, we've had AWS region outages and things like that in the past, and as a result, again, we've learned from those incidents and we've changed our resiliency standards and everything else. But just sort of, going back to a point Sohail made, which really resonated with me about kind of, how do you know, like, you can roll back safely the change that you've deployed? How do you kind of, how do you reduce the blast radius of the change and get the telemetry of the experimentation and sort of, the flag that you've set and get the data and to get all the telemetry and learn from it. And if something is going wrong, you can sort of switch that flag off. It is exactly doing that, right? It's reducing that blast radius of an unknown change, learning from what's going on. And I'll sort of go a step further, and kind of this is all the stuff that kind of, we do and I'm really passionate about, because the more you exercise a muscle, the better you get at it, right? And if you as part of your SDLC in non-prod, you are exercising rollbacks and you're exercising things like chaos, right? And you are trying to identify the pinch points in your infrastructure, in your application, in your architecture. All of these, right, are leading indicators of what sort of incidents you can expect in production, and you can get way ahead of the curve and you can start to be proactive, right? And I think that's kind of what we mean by incident before the incident. When you're doing all these things, right, when you're practicing all these advanced strategies of, rollbacks are being tested, right? My pipelines are tested. My infrastructure is, absolute bulletproof. I know the infrastructure my pipelines run on, my CD capability runs on is absolutely bulletproof, right? Then you can start to build confidence in all of your processes, all of your technologies, right? All of your ecosystem of personnel and everything else. So yeah, I completely agree with whatever my co-panelists have said already, but just wanted to echo a couple of those points because, as you can tell, I'm quite passionate about that.
I'd like to add sorry, go ahead.
Just on what you said there, Hardeep, I think what's really fascinating is you often come across these like retrospectives for incidents, and people often say, oh well, this thing happened in non-prod as well, like when we tried to roll it out, or like we saw a similar situation. But interestingly enough, when the like sort of debugging in non-prod or some sort of staging environment goes on, that's not an incident in itself. And I think in many organizations, sort of normalizing an incident happening, right? Like, you're non. Yeah, exactly. Like, the normalizing an incident happening, regardless of what environment it's in, no matter if it's impacting one person or like, a million people, a customer or like, an internal engineer or like, some special case or something like that, allows you to flex that muscle, allows you to, dust off the run books and like, sort of identify the incident before the production incident may occur in some future, and also provides context for other people who might be observing that these runbooks exist and these resources exist, and these people are the people to escalate to in a manner which is quite calm. Like, you don't need to go at this sort of ferociousness and velocity that you might have when you have like, a complete production outage. You can do it in a state of calm because you know that it's only impacting maybe a few internal folks or like a test that you're a change that you're testing or something like that.
Yeah, I think to tag on to that a little bit, it's really important not to be surprised when you have an incident. Incidents happen, especially for those of us who run distributed systems, which I think is all of us at this point. They will happen. And so the more we can be prepared for that incident, we should anticipate that incidents will happen. It's hard to anticipate exactly which incident will happen, or we would just prevent them. But Sahel mentioned one-way doors and two-way doors. And I think frequently with a two-way door, you have an easy revert button and you can just undo. For bigger changes or for things that are coordinated across the entire organization, sometimes your undo button is being prepared with a revert that is not actually a revert, it's a roll forward, is a prepared change in case things go wrong in a way that maybe you anticipated. Maybe there's data model changes or other larger changes that you can't just undo, but you can be prepared. And so one of the things that I love to see, especially with bigger changes with my teams, is before we even have that initial deploy, we've already discussed how it can go wrong. And we have PRs that have been approved and are ready to go in case of disaster. Another piece of this, and this may be more applicable in some of these smaller organizations, but understand what your deployment process is. Do you have a hard gate at it has to pass every test? And do you have the amount of time it takes for it to pass every test in case it goes wrong? Or do you have a switch you can flip when your senior engineer is in the room and they can say, skip test, we know this is safe, we need to undo it. And I think it's really important to understand what is going to be a friction point when you are trying to quickly recover, especially in the case of a large incident or a disaster recovery scenario. And anything you can do to reduce that time, whether it's time to detect, time to alert, time to deploy a fix, all of those types of things are going to make a massive difference in your company's ability to respond and reduce the impact on customers.
If I may,
Wow.
I don't want to miss something from the initial question, because I know when we've talked about this in the past, we realized that Spencer and I have like very wide, like different views on how to do a thing called like a change log. And so, and I see one question in the Zoom Q&A around exactly that, like the maturity level of a company and the size of a company becomes part of assessing what does it mean to track changes. I wanted to let Spencer like sort of talk to that from the small company perspective before I say my hot take on change logs.
Yeah, I think that's a great point. And certainly for my organization, I have worked in some bigger organizations. My current team is about 20 engineers. So we are on the much, much smaller side, certainly compared to you, Sylvia and Hadeep. And it is a very different environment. I think we have a staging environment. We have a production environment. The general understanding I have with everything that goes out, in part because it's impossible to build a staging environment that accurately respects or represents the scale of prod, is that you're going to test in prod. I think Charity Majors talks about this a lot. Whether you want to or not, you are testing in prod. And so having the detection tools and the systems in place that when you do that, you can make quick decisions, I think is really important. I'm not sure if I'm really answering the question though, so let me come back up for air.
So the thing that I remember us talking about this when we were preparing was there's an implicit advantage in smaller teams that you can slowly lose and not realize you're losing as you grow. Where when you're smaller, it's really not a lot of humans that can do changes, and so what changed last when you find out something is broken can be as simple as a single Slack DM, and you're very likely, like, it's almost like 6 degrees to Kevin Bacon. It's like 6 degrees to what was the change that broke it. I had the privilege of working in basically the same company from like when it was 65-ish engineers to like IPO, and then it got bought, and now it's really a post acquisition. We have over 2,000 engineers. And I have watched teams that grew through that, didn't recognize the advantage that they had that they now lost, and and having to sort of human to human figure out what was the last change became a really big liability and no longer an advantage. And so, like, my hot take on this is that at some point as engineering leadership, there needs to be a conversation of like, what are the different paths to make a change to production, and it's not just deploys, and are they too many? And yes, the second question does lead to taking away some local Scrum team autonomy and some local Scrum team freedom, but it's removing that freedom from the smaller context in service of the safety of the larger context, because these systems will always become entangled. You can try to apply hygiene to boundaries between domains. You can do a lot of things to mitigate that, but ultimately you don't want to have like every single Scrum team you have a completely different way to go make changes for production, because then you'll never be able to actually track how things are changing in production.
And this is a really good point, right? Because that taking away that developer choice, or sort of, kind of limiting the ways that you can deploy things into production, it has an effect, right? Has a friction point on the freedom of the engineering creativity. So that balance is always difficult to achieve, and as the organizations grow, as the communication matrix increases, right? You're not going to be able to kind of have that freedom and independence that you had the privilege of being when you're part of a small two-pizza team. Everybody knows what each of us are doing. You absolutely lose that context, and that's why we see kind of this sort of push and pull of taking that freedom away against kind of in the engineering leaders, and how everybody wants to do things their own way, and everybody wants kind of their own tooling and their own way of deploying things into production and stuff. That absolutely can't fly, right? And we see that with a lot of our customers, where kind of we are going in as having lots of different tools to do lots of different things. We sort of provide that capability of uniformity, right? Templating and standardization, and that is the only way, unfortunately, you can you can reduce that complexity and sort of bring order to the chaos, right? And unfortunately, that's a price you have to pay.
It doesn't need to be an unfortunate price, though.
Yes.
No.
For
Yeah.
many engineers, like once you sort of take away the autonomy, but you show like a golden path, and you show how the golden path can achieve what they want to achieve reliably, and you maintain a team which takes care of everything behind the scenes, like that can be very strategically empowering. For example, like as like operations folks and platformy folks and folks that build foundations, we're not going and racking all of our own servers and creating our own CPU architectures and things like that. We rely on the shoulders of others to like build our platforms on top of, call it whatever cloud vendor you use, or like whatever data center provider you use. There are people that we build on top of, and a lot of times engineers really want to build their own thing because you're not able to satisfy their needs, or you're not able to demonstrate how the existing tooling can satisfy their needs. Actually, I see that far more often than the thing is not capable, rather than the thing is not perceived as being capable. So if you're able to showcase how you're able to do something within the existing platform, many engineers will just pick that up and sort of move on with their day, because they've got targets to achieve and they've got things they want to ship, and that can be a massive strategic advantage. just making it really, really simple, wrapping it in a good developer user experience, investing in sort of those core foundations so that people feel delighted almost in choosing the golden path. And so people don't really even engineers don't entertain the principle of using going outside of that golden path because they know that they're going to endure pain.
I
Yeah.
think, I mean, I've personally, like, I've seen it actually gone both ways. I have worked, unfortunately, with teams where they still feel strongly that their bespoke path is the only way to go. Ultimately, it becomes a leadership call of like, what is the return on investment in being creative at that layer? Like, if you like using a bespoke separate engine to templatize your pod YAMLs, what is that doing for the business? And like how much is like the total cost of ownership of a thing that's bespoke versus just go use one of the things out there. That tends to be like whenever we encounter things like that, and that happens especially when with companies where the stack has been around long enough where a thing exists now that didn't exist when we built the bespoke thing, and now it's kind of like the sunk cost fallacy of like it's time to let it go. So it's not necessarily that teams start off now going, I'm gonna write my own template engine for YAML. It's that you were early on the path, and the thing that exists now in the open source community didn't exist then. But then you have to sort of take a step away and don't fall for the sunk cost fallacy. And the question that my CTO always likes to ask the teams is like, what is the benefit of being creative at that layer? What is that doing for the business?
Thank you. Thank you so much. We are running right on schedule. We didn't get a chance to get into the AI much, but I do have just a little teaser question that I can say. Can we talk when it comes to emerging applications in the AI space and how we're using that to augment SRE teams, operational teams, DevOps teams to up-level their work? What excites you most and what concerns you the most? If I can get a couple of answers from panelists to wrap this up.
So I can try to go first on that one. So I think what excites me most on the potential of AI is to surface the context faster, right? Anomaly detection tied to recent changes or automated blast radius mapping. The risk, I guess, is creating noise or diminishing engineer trust in insights, right? So AI should enrich signals, not dictate responses, in my view. Transparency is key. Engineers need to see why the AI is suggesting what it is suggesting.
I love that. No black boxes. Absolutely. We have time for one more response if anyone has a burning one.
I'm much more of an AI worrier than an AI excited kind of person. I worry about like there's this dynamic around getting a team of engineers on board with the system that they didn't own before and building the mental model. And I worry in a lot of cases where trying to lean on AI, having it explain to you what the code is doing or summarize documentation for you. I feel that there's a lot of overly misplaced trust in the accuracy of those where it sometimes leaves folks completely off track. So it's maybe like a slightly more pessimistic look than what Hardeep actually just said. Like because I agree at minimum I don't want it to be a black box. Like at very minimum I want to be able to see why it's giving the answer it's giving. But unfortunately, so far, when I ask questions about these tools, I tend to get black box answers from the people who built them, which really hurts my trust.
Yeah, I can definitely see that. Well, panelists, you have dropped so many powerful nuggets, and I hope that our audience got a lot of value out of it today. I certainly did. We'll be watching the replay. I want to say thank you to all of you, to those of you that put a question in our Slack, our Q&A Slack. I hope that we've addressed your questions. If not, please feel free to go in there and ask follow-ups, and we will be available to kind of follow up on those questions offline. But thank you for joining us for the panel today. I want to thank the panelists for taking the time out to do the prep for this and for joining me in moderating today, and make it a great rest of your day.
Thank you.
Thank you, everyone.
Thank you for having us.
Thanks, everybody.
And thank you, Christy.
Yes, thank you.